This is 9.2, Solving Quadratic Equations by Graphing, Part 1. A quadratic equation is a nonlinear equation that can be written in the standard form ax squared plus bx plus c equals 0, where a is not 0. That means that this first coefficient cannot be 0. We have to have this x squared term to make it a quadratic. It says it's nonlinear. Everything that we have done up until this point has been graphing linear equations, which is a straight line. So if this is nonlinear, that means this is not a straight line. So it's going to be a little bit different than what we've done before, but just as we graph everything else, we can graph a quadratic equation. So to solve a quadratic equation by graphing, first we're going to write it in standard form so that it equals 0. Combine like terms, if you can, and put it ax squared plus bx plus c equals 0. Next, you're going to change that equals 0 into a y equals, which is a related function. So then we have a y equals and the same expression. And now we have x's and y's. When we have x's and y's, we can put those on a graph. So to make that, we're going to make a table. When in doubt, make a table in graphing. To find the solutions, we are going to find the x-intercepts if there are any. Those solutions, also called roots, are the x-intercepts of the graph. An x-intercept, to remind you, is where the graph crosses the x-axis. So we're looking at what are those points. If it crosses the x-axis, y is 0, so we're really only worried about what is x. So we're going to solve x squared plus 2x equals 3 by graphing. Step 1 says to write it equals 0 in standard form. So I subtract 3 on each side, and I get x squared plus 2x minus 3 equals 0. Step 2, replace that 0 with a y equals, and make a table. So I chose these x values, and I'm going to find the y values that match. So for negative 3, we have negative 3 squared, which is 9, plus 2 times negative 3 is negative 6. So 9 plus negative 6 is a positive 3. 3 minus 3 is 0. Now I'm going to do the same with negative 2's, negative 1, 0, 1, and 2. Usually I only go from negative 2 to 2 so that I choose ones that are close to 0, so my graph isn't super huge. But I needed to include this negative 3, and I'll show you why when we look at the picture of the graph. So, after you get all your y values that match those x values, we are going to plot them on our coordinate plane. And so, we have negative 3, 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3, 1, 0, and 2, 5. When we draw the line, you want to make sure it's curved like a U and not a bunch of little straight lines like a V. We needed to include this negative 3 because that is one of the points that it goes through the x-axis. So I can look at my graph and say this is an x-intercept and this is an x-intercept. So the solutions are negative 3, 0 and 1, 0. When we solve x squared minus 8x equals 16 by graphing, I'm going to add 16 to each side, replace that with a y, and make a table. This time I chose numbers that are a little bit larger, because if I get 0 is 16, I go to 1, I get 9, and then 2, I get 4, I know that these numbers are going down. They're getting closer to 0, and I want to make sure I know where y is 0. What is the x there? So I found 0. And I decided, am I going to see any others? And it goes back up to 4. So when I graph this one, I see that it just touches at x equals 4, but it doesn't go through. So it only touches it once. So this has one solution, which is 4, 0. And now for this last one, I'm going to add x squared to each side. I get x squared plus 2x plus 5 equals 0. replace that with a y, and make a table. For here, we're going to see that we get y values of 5, 4, 5, 8, and 13. I notice that this 4 is the lowest value that I'm going to see, and it's right in between -2 and 0. So if I were to graph this, it's not going to cross the x-axis. So we're going to say that this one has no real solution because there's no point at which this graph is going to cross the x-axis.